This is the examples of the match circuit. So assume that we are trying to find the voltage across and the current through all the element. First is we have to analyze the circuit. Either the circuit consists of constraint or dependence. Either it consists of dependent current source or dependent voltage source. Is it the circuit consists of supermesh? As you can see that there is 4 loops in the circuit. So assume that we are trying to find the voltage across and the current through all the element. What you have to do? So as you can remember, the first steps of the match. So first step is you have to assign loop in the clockwise. So for the first loop, I1, and this is the second loop, we mark with the I2, third loop I3, fourth loop is I4. Then for the step number 2, you have to decide number of equation by considering all the possible things, for example as dependent source, supermesh, and so on. So number 1's numbers of loop is 4. So any supermesh? Yes. So here is supermesh. How to know the supermesh? There is a current source in between the loop. So this current source is in between the loop I2 and the loop I3. So from 4, then minus because of the supermesh, but then you have to add another 1 because of the supermesh equation. So the total will be 4. And then for the loop number 4, we already know the current value. No need to do the KVL because the mesh currents here is equal to the branch current. So the currents at this branch is 2Ix. So no need to do the KVL equation at this loop. And then you can see that there is a dependent source which is a current source. Therefore, you have to add another one equation that called as a constraint equation. So for the constraint equation, what is Ix? For the step number 3, decide numbers of equations. First equation at loop 1. Second equation at loop supermesh, which is you combine 2 loops and 3 loops. And then loop 4. And then additionals of supermesh equation because the existence of the supermesh in the circuit. And then lastly, one constraint equations because of the dependence current source. The total is 5 equation. When I comparing side by side with the circuit, you can see that for the first I1, as shown here, first is minus 5 volt. You can see that there is a minus here. We do the KVL at the first loop, minus 5 volt, and then plus with the 10 times with the currents, which is current I1, and then plus with the 8 times with the I1 minus I2, because 8 ohm is sharing the currents in between the I1 and I2, then you have to do a subtractions of I1, subtract with the I2, and then equal to 0. So finish for the first loop. As for loop at supermatch, which is you have to combine loop 2 and loop 3. So loop 2, I2 is dominant. You have to combine X ohm with 4 ohm for the loop I2. So for the first equation, so X times with I2 minus I1 plus with 4 I2. That is the equation for the I2. And then you have to combine the KVL at the loop 3, which you can see that there is only one element in the I3. Therefore, combines the voltage at the 4 ohm, which is at loop 3, the dominant is I3. Therefore, I3 will be subtract the other currents that share with the 4 ohm. So for this equation, the equation for the 4 ohm will be 4 times with the I3, because the I3 is dominant, minus with the I4, then equal to 0. And then for the loop number 4, because of there is a current source at the outer branch, so it means that the branch currents is equal to the mesh currents. So I4 is equal to 2Ix for the next equation. Because of there is a super mesh in the circuit, there will be some additional equation, which is super mesh equation, in order to show that what is 3M. So 3M is share the current in between the I2 and I3, and then the direction is same as the I3. So it means that I3 minus I2 equal to 3. And because of there is a dependent source, which is current source, what is Ix? So Ix is, you can see that here is Ix. So Ix is flowing through the 8 ohm. So it means that you have to find the currents in between the I1 and I2, and because of the Ix has the same direction with the I1, therefore I1 is minus with I2. Then step 4, calculate the mesh currents, solving the simultaneous equation by applying Cramer's rules or using calculator. So this is the equation. So this one, you have to do these ones. 1, 2, 3, 4, and 5. And then you have to group the equations, grouping I1's group and then I2 group, and make it into these simple equations. Then name it as a 1. And for the KVL at supermesh, solve it until it become the equation that look like this one. And then name it as a 2, and at loop 4, the I4 equals 2Ix. And then supermesh equation, so I3 minus I2 is already simple. And then for the loop number 3, actually you can make it simple by I4 minus 2Ix equal to 0. Then again, substitute 5 into 3, and then you can get the equation that look like this one. Because of the calculator only consists of 3 times 3 Kramers, from the 5 equation, you have to reduce the equations so that it can be left with the 3 equation. Therefore, you can substitute the Kramers equation into the calculator. Okay, from 4, and then you solve that so that it becomes equation number 7. And then substitute 7 into 2. Then the equation will be simply look like this one. Equation number 8. And then you rearrange equation 1, 6, and 8 into the Kramers. Substitute that Kramers into the calculator. And then this is the answer for the I1s, I2, and I4. In order to find the I3, you substitute the equations or the values into the I3 equation. Then you can get the I3 is 2.553 amps. This is the answer that we are looking for, which is you can see that this is I1, I2, I3, and I4. So in order to find the branch currents, there is an additional question, and then you have to find it by yourself, and then we will discuss about these ones at the next lecture. Okay, first question will be find the voltage at current source Vy and Vx, determines the power delivered by all source.